Sir, I need to get my physics book as well.
No issues. Get it fast. I can wait 2 more minutes for everyone. Please. तो अंजल आप कब से हो इस स्कूल में? कौन सा ईयर आपने ज्वाइन किया था ये स्कूल? अंजल कैन यू हियर मी? अंजल आप मेरा बात सुन सकते हो? अंजल कैन यू हियर मी?
Yes, sir, can you hear me?
मैं आई कैन हियर. मैं ये पूछ रहा था आपसे, आप कब से हो इस स्कूल में?
I just joined this year.
नहीं, आप कहाँ से कब से हो? कौन सा ईयर से है ये स्कूल में?
This year.
हाँ, दिस ईयर से क्या? अच्छा, बढ़िया है. Ryan has joined.
Yes, sir.
ठीक है सब लोग, यार ये कैमरा ऑन कर लो. कीप द कैमरास ऑन. एक्चुअली फिजिक्स में 11th में बहुत इंपॉर्टेंट एक टॉपिक्स है. ये टॉपिक बहुत इंटरेस्टिंग है क्योंकि ये टॉपिक जो है कि दिस इज सपोर्टिंग टू मेनी अदर topics of class 11th. Okay, so this topic is called like it is written like this, or it is called like this. Let me write down the name here. What's happening here? Motion in straight line. Okay. All of you with me? Rupan, Shayan, Ryan, Anshul. I think one is absent, right? Who is absent? Whether she will be joining? Yeah, Shantini. Okay. So can you all interact with me also during the class? I could see you guys only speaking there. Can you all hear me properly?
Yes, sir.
So let's
sir.
talk. Okay, let's talk and let us interact. Let's not be just I'm just doing a drama here, you're watching it. Let's not be in that mood. Okay, let's interact. Let's talk each other so that things will be much better. Have you heard about this name anywhere? Motion in straight line. Hello. Guys, have you heard about this topic earlier?
Yes, sir.
So what is that you understood motion in straight line so far?
Sir, about the concept of displacement, acceleration, velocity, speed.
Okay, see, motion, a topic like motion you would have learned in 9th standard, I hope so. Motion, a topic called motion would have been learned in 9th standard, am I right?
Yes, sir.
Are you remembering? Okay. So what is quantities of motion? Quantities. What are all the quantities of motion?
Speed.
Very good. Speed. Speed. What are the quantities of motion?
Displacement.
Okay, displacement. Next.
Time.
Time. Then what else? What else?
Velocity.
Velocity. Acceleration. Then what else? See, there can be a question like this. The question It can be asked in any exam. The question will be like, write down the quantities of motion in straight line and explain in brief. Okay, write down the quantities of motion in straight line and explain the conditions of each quantities. So the quantities are like to understand the basics, that we know speed, acceleration, time, then what else? Displacement, then what else? Velocity, then what else? What is next? Have you heard about instantaneous velocity? Heard about instantaneous velocity? Have you all heard about instantaneous velocity?
Yes, sir.
Then what is instantaneous? What can be instantaneous velocity?
At a particular moment.
Very good. Next. See, basically this motion in straight line, this topics gives you a view to loss of motion. Okay. This gives you a study to work energy and power. Then these topics support you motion in a plane. Okay. Then this topic supports you motion in a particle. Okay, particle of rigid body. Rigid body. Now understand this topics, this motion in straight line gives you 1, 2, 3, 4. It supports you when you complete this motion in straight line in a proper manner. This will ensure that you are capable of doing these 4 chapters. Now let me tell you, loss of motion is having 3 to 4 questions in NEET. Okay, loss of motion. Loss of motion is having 3 questions in JEE. Okay, work energy power is having 2 questions in JEE as well as NEET. Motion in a plane, you have 3 questions in JEE and you have 2 questions in NEET. And motion in a particle of rigid body, you have 2 questions in JEE and you have 2 questions in NEET. Which means, okay, my dears, please understand, which means 1, 2, 3, 4, and this 5 topics put together, you have average 30 mark questions. 30 marks. Okay, 30 mark questions are asked either in JEE or NEET from these topics. Now you understand the importance of learning these topics in very detail, and especially doing the numericals. Okay, what are the importance of doing numericals and why we need to understand the numericals? So before we do numericals, we must understand the basic strategy of these topics and how this is worked out. Okay, and the concept of motion in straight line. See, motion in straight line is also called in some other name. Do you know what is that name? Motion in straight line is also called rectilinear motion. Have you heard about this? Rectilinear motion, RECTILENEAR, rectilinear motion, MOTION motion. Rectilinear motion. And again, one more name is there for this topics. Have you heard about it? Motion in one dimension. Motion in one dimension. So this topics, motion in straight line, in some places it is called as rectilinear motion, and some places it is called as motion in one dimension. My dears, you understood? This motion in straight line is called in 3 different names, or it is taken in 3, considered in 3 different names. Now, students who wanted to study about rocket science, someone who wanted to study rocket science, okay, someone who wanted to be aeronautical engineer, okay, someone who wants to be astronaut, someone who wants to understand work at NASA, someone who want to work at ISRO, okay, hello, if all these are your dreams, or if these are in your dreams, if these ideas are in your dreams, then you need to understand about these topics, rectilinear motion and motion in one dimension. Otherwise, you cannot move forward. Is it clear now? Is this clear? Why nobody is talking to me?
Yes, sir.
Yes, sir.
Respond, no? Give response so that I'll also be happy. You respond, okay? So now let's understand. Let's write down a small definition of motion in straight line, okay? See, this motion in straight line basically called, in physics, there are two parts, okay? Part one is kinematics. Kinematics. Second one is dynamics. There are two areas. In kinematics, you have motion in straight line. Okay? Dynamics is basically all about laws of motion. And this is branch of mechanics. So branch of mechanics, there are two topics. Topic number one is kinematics. Topic number two is dynamics. Is that clear, my dears?
Yes.
Branch of mechanics. In physics, if somebody asks you what are all the branches of mechanics, there are two branches. One is kinematics, next one is dynamics. Now kinematics works with automations. Automation. All automobile industry works under the principles of kinematics. Are you all with me?
Yes, sir.
All robotics works with kinematics. All kind of your rocket science, aeronautical engineering, okay, such NASA's mostly related works, ISRO's related works, all works with dynamics, laws of motion. Are you all clear?
Yes, sir.
Understood? Okay. Now let's see what is kinematics or what is laws of motion. Let me tell you one small definition of laws of motion. So give me, take down the notes along with me. I don't want to tell you, write down like a kindergarten students. I don't want to tell you, write this, write that. So if with me, you can write, okay, whatever is shown on the board, all the points, take it down. Okay, kinematics. Here, if you don't know the spelling, you ask me that I'm using on digital board, it's not really working. Little disturbance is there. So if you understand it's properly, then take it. Otherwise, ask me the spelling. Okay. I'm trying my best to write. Kinematics. So kinematics is basically considered the branch of, okay, physics that defines motion, physics that define motion with respect to space and time. So what is kinematics? Kinematics is the branch of physics that defines motion with respect to space and time. Now, my dears, understood what I meant by motion? That if you work out for automation, if you work for automobile industries, if you work for robotic industries, if you look forward for getting into ISRO, NASA, such kind of institutions with respects to space and time. Are you all clear?
Yes.
So kinematics is the branch of physics that defines motion with respects to space and time. In this, now we are learning today, what we are learning is, we are learning about motion in straight
One
line.
dimension.
Motion in straight line. So let us understand the basic equation of motion in straight line. All right. There are a few basic equations which we need to understand. Motion in straight line. Okay, let me tell you. There are three equations. There are three equations. The three equations are, the first one is, okay, V is equal to U plus AT. All right. The second one is S equal to UT plus 1 by 2 AT square. And the next one is V square equal to U square plus 2AS. So U is defined is here as initial velocity. Okay, U is defined as U is initial velocity. V is the final velocity. V is final velocity. A is what? A is what?
Acceleration.
Acceleration.
Very good. A is acceleration. Next, what is left in this? S is the displacement. S is the, what is S? S is the displacement. So this is the major equations of this portion. With keeping this in mind only, we are going to do the number of numericals of these topics. Okay. So V is equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS, and U is initial velocity, V is final velocity, A is acceleration, S is the displacement. Am I clear? Am I clear?
Yes.
All right. Okay. Very good. So let's see now one basic idea. What is understood by velocity? What is speed and what is velocity?
Speed's the amount
Speed
of,
is distance by time and velocity is displacement by time.
Can I get the definition of speed?
the amount of distance covered in a unit time.
Definition of speed.
The amount of distance covered in unit time.
No. What is the definition of speed? You have given me the formula for speed. Rupansh, I think you said to me the formula or equation of speed.
Yes, sir.
What is the definition of speed? Tell me the definition for speed.
I don't know, sir.
And what is the definition for velocity?
No idea, sir.
Okay. So anyone, any others, anybody else? Anybody else can tell me what can, anybody else having idea what can be? I want to give you the correct definition for speed and velocity. What is the speed and what is velocity? You guys have given me the what you call, you've given me what? You've given me the let's see. Speed, whether speed is a scalar quantity or vector quantity.
Scalar.
Why speed is a scalar quantity?
Because it doesn't have direction.
Sorry?
Because it doesn't have direction.
Does not have direction. And velocity?
Velocity is vector.
So speed is scalar or vector. So you say speed is a scalar. Is speed a scalar? Are you sure? Whether speed is a scalar quantity? Are you sure? No one is talking to me. Are you sure?
Yes, sir.
Okay, why velocity is whether velocity is a vector or scalar?
Vector.
Vector.
Why velocity become vector?
Direction.
Direction is added. So speed is having only magnitude and velocity is having magnitude plus direction. Okay. What about temperature? What about temperature? Is it a
Scalar
scalar
quantity.
quantity or vector quantity?
It's a scalar.
How many of you agree? Whether temperature is a scalar or Rupanshi is telling it's a scalar quantity.
Yeah, I agree.
Why?
Doesn't have any direction.
It's not have direction. Suppose I said that today morning Ooty was 20 degree Celsius in the early morning. By 8 o'clock the climate was 20 degrees Celsius.
So there's no direction we're talking about.
So Ooty is not a direction for
No, sir.
temperature. No. Then what it is?
A place.
It is a destination basically, right? So it is pointed to a place. So that is why it is into magnitude, and it is temperature is taken in scalar quantity. What about displacement?
Displacement is vector.
Displacement?
Vector.
Are you sure?
Yes.
Why displacement is vector quantity? Everyone should interact actually. Only one or two students are talking to me. Others are not at all talking. I don't know why you guys are not talking to me. Then how do I take the class more interestingly? If you're talking to me, I can go ahead with a lot of interesting factors can be discussed. Provided you discuss with me. Hello?
Yes,
Yes,
sir.
sir.
So velocity, why it's scalar or why it's vector?
So velocity is considered to be vector quantity because along with the magnitude, we tell the direction in which the body is moving with the velocity.
Okay, suppose you have a car. Okay, let's assume that you have a car. Now I told you to drive this car, okay, with a kilometer speed of 80, okay. 1 hour maximum kilometer is allowed to you 80 kilometer per hour. You have to drive the car 80 kilometer per hour speed for the next 1 hour. Rupash?
Yes,
Okay.
sir.
So you continuously drive, okay. You continuously drive without stopping because I told you to drive this car for the next 1 hour without stopping, and your allowed permissible speed is 80 kilometer per hour. So what is the speed of the car?
80 kilometers per hour.
80 kilometers per hour. Okay. Now if I ask you drive this car from Ooty to Coimbatore with a speed of 80 kilometer per hour in 1 hour, then what happens to this? There what changes happens? What changes comes here in this case?
The initial and final position is given.
Initial and
Final position of the car is given. Like the
is
path it has to travel.
okay. So what happens? What happens in that case? Speed become velocity, am I right?
Yes, sir.
Yes, correct. Why? Speed
Because-
become velocity, why? Because I have added direction here. Isn't it?
Yes, sir.
I've given you a car and I told you just to drive the car with a speed of 80 km/h for an hour. You continuously driving, you don't know where to go. Only condition is that just to drive the car without stopping. That means for an hour, you have to drive the car with a speed of 80 km/h and you continuously drive the car without stopping. Only speed is a constant there and continuously maintain that speed. In the second condition, I told you take that car and come down to Coimbatore with the same speed. Now speed become velocity. My dears.
Yes, sir.
All right. See, now let's see. Suppose in your hand, okay, let's see that you have in your hand that you have a ball, okay? A ball is there. I ask you to place this ball on top. Okay, just lift it up on straight line. Okay, you draw it straight line. This ball you are asked to throw straight line. Okay. Now, from this to this point, velocity increases or decreases?
So from which to which point? Sorry.
From this point to this
So,
point, what happens to velocity?
it will increase.
Velocity increases. If increases, why? If it decreases, why? Ryan is not talking here. Ryan, what happens to you?
Nothing, sir.
Then talk to me, no? Speak to me. I'm asking a question here. A ball is there in your hand. I asked you to place this ball on top of the top to the air. And my question is that from the starting point to the starting point, whether velocity increases or decreases. If it increases, why? If it is decreases, why?
Sir, decreases.
Why it decreases? Why it's not increasing?
So it should increase, right? Because we are giving it initial velocity so that it goes up.
Okay.
So as it reaches the topmost height,
Okay.
then the velocity will become 0, and when it comes down again, it will increase.
I would like to hear from other students also. My dears, others? Girls not talking to me. Anchal and the other one, Chandini. Please speak. Speak up here. Talk to me. Any ideas are welcome. See, in physics class, if you think that okay, you are just observing, it will not work. Discuss work, discuss work, discuss work. That's only will work out. In the other case, it will be just like a history or geography class. You know, a drama is going on, you are listening the drama, that's all. It will not happen. Discuss with me. My question is very clear. I was asking and Rupan, she's telling it keep increasing velocity. And anybody wants to challenge it, can challenge among all of you.
Wait, so the ball is being thrown up?
I can't get you, Shine.
So the ball is being thrown up.
Yes, thrown up. The ball is thrown up. What happens, my dears?
Yeah, then it'll increase, right?
See, you guys are not concentrated on this activity. Such kind of physics has to be done always with a lot of exercises. See, look at this. At each point, velocity decreases. Okay. Come on, ask me now how.
Sir, but how will it decrease, sir?
So the
Okay,
gravity.
Rupansh, listen. If you know in the initial stage, okay, there will be a maximum velocity, and from this it goes and it decreases, and only when it reaches to a saturation point. Okay, if your velocity is keep on increasing, then the ball won't come back. My dear.
Yes, I got it.
Now, when it reaches to a saturation point, this is at rest. Okay, velocity at rest. Hello, are you all listening to me?
Yes, sir.
Yes.
Velocity as at rest. Now from this it starts back. Okay, in this time what happens?
Velocity increases.
Velocity increases because of mg, gravitational force, and mass of the ball. So velocity increases till it touches the ground. You got me?
Yes, sir.
Okay, I'll give you, before I give you the definition of speed and velocity, one more example to understand. Let's understand one more example. Have you heard about American football?
Yes, sir.
American football?
Yes, sir.
Anyone watched it?
No, sir.
Anyone watched it? Okay. There a person called Cam Newton. Cam Newton, a player. Okay? Cam Newton, a player. He can throw a ball 18.288 meters in 1.25 seconds. What does that mean by? This guy, Cam Newton, is one of the fastest thrower of the game, and he can throw a ball to 18.288 meters in 1.25 seconds. So what is the speed? Calculate. Calculate fast. Velocity equal to d by
14.63
d
meters.
by t. So which is coming how much?
14 by 6 meter per second.
14.
By 14.6 meter per second.
I'm not sure. Shine is okay. Rupansh is not okay. The others are not at all talking to me. Anchal is not talking. Parnava is not talking, and Chantini is not talking. So 14. Is it sure? Are you all agreeing that 14 point what?
63.
14.63 approximately meter per second or kilometer per hour?
Meter per second.
Meter per second.
Very good. Meter per second. Why? Because what is the unit of velocity? What is the unit of velocity?
Meter per second.
Meter per
Meter per
second.
second. So 14.63 meter per second. So what is that we need to understand? What is the speed of this guy? Or what is the velocity? You know how velocity changes in 1.25 seconds. Are you able to understand? So see, most of the guys make use of, okay, motion in straight line topic. Like if you listen these topics, these motion, velocity, acceleration, and speed, and all, most of the guys make use of in sports. Okay, sports, they make use of it. So they understand, see, his speed actually. Now let's see, suppose you're playing football, okay? There are 11 members in a team. Okay, suppose you need to kick a ball, okay? You need to kick a ball in 1 minute, okay, to 200 meter, okay? 1 minute, how much I said? 1 minute, 200 meter. And the person is standing maybe diagonally opposite to you, or in the corner of the ground, don't know where it is. So, but you have to make him reach in 1 minute or let's say in 20 seconds. You don't hardly get 1 minute and all. It is just a second. Okay, let's see that 0.5 seconds. You have to reach to 200 meter. Or hardly how much time, if you are a good player, how much time you will get a ball with you. Okay, see, for example, suppose you are getting a ball only 25 seconds to keep it with you, and in this 25 seconds you have to make minimum 10 pass. My dears. Okay, suppose you are getting the ball for 30 seconds and you are being asked to make minimum 20 pass by this time. How you need to play? You need to understand physics better.
Yes, sir.
Otherwise, somebody else will take away the ball. You understand what I'm saying? In 30 seconds, 20 passes to be done. Otherwise, you have been taken out of the game. You would have listened to the commentary, right? They would be telling that this person in 5 minutes holded the ball and he has kept okay, he has given minimum 20 pass. Okay, he has made 1 goal. Likewise, the counting would have been taken. When he is keeping 5 minutes with him, the ball, the best player does 20 pass and make 1 goal. Not like that, simply you are keeping the ball with you. There is physics behind it. Speed and velocity. So I said Cam Newton, a guy who can throw a ball to 18.288 meters in 1.25 seconds. You understood what I'm saying? My dears?
Yes.
Right, okay. See, now next is, let's understand, we were talking about speed and velocity, am I right? No one is talking to me here. Why physics class is not interactive? Let's interact now. So our topic is, what is our topic here?
Speed and velocity. Oh, wait.
Motion in straight line. What are all the equations I have given you? 3 equations of motion.
V is equal to U plus AT. S is equal to UT plus half AT square. And V square is equal to U square plus 2AS.
So motion in straight line. Okay, I am telling motion can be always visualized from a frame of reference. What is mean by this? Motion can be visualized always from a frame of reference. Have you heard about this word, frame of reference?
Yes, sir.
So what is this frame of reference?
A certain point of view.
Point of view. Anybody else want to join? Frame of reference is what, Chandini?
Sir, I'm not sure.
Not sure. And Anshul? See, frame of reference, let's see. Okay, let's take an example. Suppose you are traveling in a car. Okay? Traveling in a car. So according to you, the car is moving, and according to the car, you are sitting inside. You are at rest. Am I right? Isn't it? Yes or no, my dears?
Yes, sir.
Yes. Suppose you open the window and see what is happening outside. What will happen to the outside objects?
They seem to.
They will seem to move.
They are moving opposite direction. Am I right? Most of the objects are moving in the opposite direction. Am I right? Yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Suppose you stop the car. Now you come out of the car and you stand in a bus stop. Okay? You stand in a bus stop and you watch a bus coming in front of you or a car coming in front of you. What is happening? The bus is coming, the car is coming, all are in motion. All the objects which is coming in front of you or passing in front of you are all in motion. Am I right? But if there is a tree behind you, Earlier, the tree was actually in motion when you was inside the car. Now you are out of the car. You're standing in a bus stop. Now you're looking at the tree. What is happening to the tree?
It's not moving.
It's not moving. The tree is at rest. Am I right? The tree is at rest. So my concern is that, or what the motion saying, motion can be seen only from a frame of reference. Okay, motion can be visualized only from a frame of reference. In the first case, your frame of reference was what? The moving car. Okay. The second case, your frame of reference is what? What is the frame of reference? The second case.
Tree.
The bus stop. Where you stand? See, listen, how motion is visualized. Motion is either visualized sitting inside a moving car or a bus or a bicycle or a motorbike or an aeroplane, whatever it is. In the other case, when you come out of the vehicle and you stand on the ground, the place where you are standing is actually your frame of reference. You got me?
Yes, sir.
Frame of reference. So you are visualizing motion from a frame of reference. Motion can be visualized from a frame of reference. So what is frame of reference? Frame of reference is nothing but a motion is observed from from a place or from a particle, from an object, from a plant, from where you are observing that particular motion. Is that clear? My dears, is that clear?
Yes, sir.
So next thing is motion in straight line is always straight line, or motion can always happen in straight line? Whether motion can always happen in straight line? My question is whether motion is always in straight line. Is always straight line. Whether motion
No,
is
sir.
always straight line.
No, sir.
Okay, if a car is moving from this direction, okay, to through this, is it in straight line? If a car is moving from this direction, okay, to this direction, it's moving. So this is what axis? X, Y. So in XY direction, the car is moving from here to this direction. Is it in straight line?
Yes.
Doubtful? Ideas? Is it in straight line?
Yes, sir.
It's in straight line, right? Because whether it is this line or is it going like this or is it going like this, is it going like this, is it going like this, all are in straight line only. Okay, so motion is always, motion in straight line is called like this, motion is always in straight line, and that is why this is actually given as rectilinear motion. Rectilinear motion. Okay, motion in straight line. Okay, is it clear? Hello? No one is talking to me.
Yes, sir.
Yes, sir.
Okay. The next topic is have you heard about a word called, so we have discussed now in motion in straight line, speed and velocity I've discussed, but I've not given you the definitions. I'll give you. Before that, let's understand, have you heard about this word, path length? Path length. Have you heard about this word?
No, sir.
In many questions, you can expect this word, path length. Path length versus displacement. So what is this path length? Suppose you have a home here, okay? And you have school here. Now from your home to school is, let's consider 2 kilometers. Right, yes?
Yes, sir.
Okay. Now, a good student directly go to school from home to school. Okay. A bad student or a little different student goes from here to shop first. Okay. Then he goes to his friend's house. Okay. From here again he will go to uncle's house. Okay. Then he come back to school. Are you all with me?
Yes,
Yes,
sir.
sir.
So in this case, the first one actually has come from, from home to school, he has come directly. This boy has gone to shop, then friend's house, then he went to meet his uncle, then finally he reaches to school. So this particular route is called path length. Okay. So what is kind? The total distance travels from initial to final. What is path length? Path length equal to total distance travels from initial to final. And what will be this?
Displacement.
This will be
Displacement.
displacement. Displacement is nothing but what? What is displacement?
The shortest.
The shortest distance.
Shortest or actual distance. Okay. So understood what is path length versus displacement?
Yeah.
Now, can we say path length and displacement are equal? Can we say path length and displacements are equal? If I say path length and displacement is equal, will you agree?
No.
Sir, in some cases, yes.
How? Give me a case.
Sir, suppose we have to travel from one point to other point
Okay.
while in a straight line. So in that
Mhm.
case, distance and displacement will be equal, right?
Okay. See. Again, home to school. Okay. You started from home to school, which is 2 kilometers. Okay. So when you reach to school, the security told that school is closed. Very interesting factor. Okay. Security said school is closed. Now what you will do? You have come back in the same line. Okay. I'm sorry. So you have come back in the same line. So what is the velocity here?
Zero.
Why?
So because in this case, displacement becomes zero.
Displacement is zero. Because of that, velocity is also zero. What is the path length?
4 kilometers, right?
Very good. 4 kilometers. Okay. Now let's see. Suppose you were sleeping at your home by 6 a.m. Okay. You were sleeping at your home by 6 a.m. and your father left the home by 6:30. Okay, till that time also you were sleeping. He left home by 6:30 and you got up by 7 o'clock and you went to the school. Okay. Hello. Are you all with me?
Yes, sir.
So you went to the school, okay? You came back from the school since the security told you that the school is closed today. So you came back home, again you started sleeping in the same position. My dears, your
Yes, sir.
father
Yes, sir.
returned back 10 a.m. to school. So 10 a.m. to home. He left 6:30 and he came back 10 a.m. Okay? According to him, the path length is also 0, velocity is also 0, and displacement is also 0. Why?
Does he work at home?
No. See? what has happened here? See, according to him, you are still in the same position. Only your mother will know that your path length is 4 kilometers. Because she only know that you went there, you came back and you started sleeping in the same position again. Unless until somebody tells him that he is, unless until your father knows from your mother that you have traveled to the school and returned, okay, he only understands path length, velocity, displacement is 0. Understood?
Yes, sir.
Yes. So, path length at time can also be 0. Depends on the situation. Next condition. Is it boring? Hello?
No.
Are you able to understand?
Yes, sir.
Okay. Next is speed and velocity. So path length and displacement I have given you correct briefing. So you understood what is path length. Clear?
Yes, sir.
So path length is the total distance traveled by a person and displacement is the shortest or actual distance. So speed and velocity. We need the definition for this. Am I right? Yes or no?
Yes, sir.
So speed, the definition. Rate at which an object covers distance. Velocity, rate at which an object changes its position. What is the difference between two?
Velocity has direction.
Changes its position. In velocity, what happens? On a particular time period or a particular speed, the object changes its position. Okay? The object, importance is what actually? From speed to velocity, the importance is what? Changing position. Okay? Changing or changing position. Clear? Changing position. All right. So, let's see if an object travels, okay, A to B. Do you know what is particle mean by physics? In physics, what is particle? What is particle? My dears, what is particle? What is mean by particle?
A small
PAR,
object.
particle, PARTICLE, particle. In physics, okay, particle body, object. Three things are same. Okay? If anywhere in a question you see that, or you read a particle move from A to B, or a body move from A to B, an object move from A to B. So particle, object, body are the same thing. You understand? Is it clear? So a particle moves from A to B. Okay? So 1 minute, 2 minutes, 3 minutes, 4 minutes. So 1, 2, 3, 4. Okay. See each minute. This take it as a time. Okay. Take it as time. So a particle moves from 1 minute to 2 minutes, same distance, 2 to 3 minutes, same distance, 3 to 4 minutes, same distance, and 4 to 5 minutes if it is the same distance. Okay. This is called constant velocity. Constant velocity or constant motion. What happens? Every particular time or every interval of time, the object covers same distance. And this is called uniform motion. What is uniform motion? An object covers same distance at same given time. Okay? Uniform motion. What is uniform motion? Uniform motion, an object travels same distance at same time or same interval of time. Which means speed is not variable there. You can see a person driving a car, first 1 hour 60 km/h speed, second 1 hour 40 km/h speed, third 1 hour 70 km/h speed. That means the car is not in uniform speed, car is in non-uniform speed. Okay? In the other case, what happens, Shayan? The car is in uniform speed. A car travels a particular distance at a particular given interval of time. You got me?
Yes,
So
sir.
that is constant velocity, constant motion, uniform motion. Is that clear?
Yes, sir.
Yes, sir.
So here I'm writing like this. What I'm writing is speed equal to, okay, I'm changing like path length divided by time taken. Speed equal to path length divided by time taken. Now Rupansh understood. The total distance traveled by a boy, he went to his uncle's house, shop, then he went to a
Yes, sir.
friend's house and he reaches. So speed is matter according to the total distance traveled. Okay?
Yes, sir.
Speed is not like just because of distance and time. It is the total distance.
Yes, sir.
Path length divided by total time. Shayan, are you clear?
Yes, sir.
Next is velocity. Velocity, displacement by time. Total displacement by total time. Okay? Total displacement by total time. Are you all clear here?
Yes, sir.
Yes, sir.
Yes,
Is
sir.
it getting clear? Okay. Suppose we have taken, let's take like this. Again, home to school. Okay. 2 kilometer distance, 10 minutes. Okay. What is the speed? What is the velocity? What is the speed and what is the velocity? Calculate fast.
0.2 per second.
Calculate
0.2
fast.
kilometers.
0 point
Sir, it is given 2 kilometer and 10 seconds.
10 minutes.
10 minutes.
What is the speed?
0.4 kilometers per minute.
No. What is the speed?
It is 3.33 meter per second.
3.33
meter per second.
Are you sure? Velocity?
Same.
Velocity is also same. So speed we generally, if we have to convert it to kilometer per hour, this 10 minutes what you did? 10 minutes into or divided by
I converted to meter per second, so I multiplied by 60.
10 minutes, how much you got? Meter per second?
I took it as 2000 divided by 10 into 60.
2000
So
divided
that I
by?
got 10 into 60.
Okay.
So that I got 3.33.
600. And here what you got? 2000.
2000.
Am I right? So how much it is?
$3.33.
Okay. Velocity is how much?
Velocity will also be same, right?
That will also be the same. Others are not telling me. No one else is telling me other than you. Okay. Let's see. Suppose distance, time, graph. Okay. Distance, time, graph. Again, home to school. First 1 kilometer in 10 minutes. Second 1 kilometer in 10 minutes. Third 1 kilometer in 10 minutes. Okay. How can we show this in distance time graph? If you can draw and show to me through this camera, I'll be happy. Distance time graph. How do we draw distance time graph?
So we plot distance on the y-axis, time on the x-axis.
Okay, this is which one? This is the y-axis is what?
Distance.
Okay, this is distance and this is time. So here what we get? 10, 20, 30, and let's see 40. This is time, right? Time, and this is x-axis. So here we have 1 kilometer, 2 kilometer, 3 kilometer. So distance time graph will be what actually? First 10. Okay. Hello. Okay.
Yes, sir.
Next one. Next 20. And third, next 20. Next 10. So this is the distance time graph of this question. Is it clear?
Yes, sir.
Is it clear?
Yes,
Yes,
sir.
sir.
The next one is your time up now? Or can I complete one more thing?
Yes, sir, you can complete.
Have you heard about a word called slope? Slope. The next quantity of this topic, slope. What does slope mean by? What is the meaning of slope? Slope is what? What is slope mean by?
Sir, to check like how
So,
steep
sorry?
the line is or any surfaces.
Inclination of a line. Okay? Inclination of a line. Now let's see a constant line. Okay? A car is starting from A to B. A car is starting from A to B and A to B direction. So this is a constant line. So what kind of acceleration to be given here? If the car wanted to travel 60 km/h on this constant line, okay, what have to do here? What kind of acceleration to be given? You definitely need to give a push, right? Acceleration has to be
Yes, sir.
constant. Acceleration has to be constant. Am I right?
Yes, sir.
Constant acceleration. My dears. Okay. So A to B, you want to drive a car and it is a constant road, the straight road, straight line, or the road is very straight, in which you have to give a constant acceleration, only then the car moves. I'm not talking about high speed or lower speed or anything. Okay, your acceleration has to be constant, then the car moves. Understood or not?
Yes, sir.
Okay. Car reaches to this point. Okay. From here, if the line goes like this, car reached to this point. From here, the slope is like this. Now, what will happen? Do we need acceleration here? Do you need acceleration here?
Yes, sir.
Why?
So then only the car will like be pushed forward, right? In that case, the acceleration of gravity will be considered.
If the slope is like this, and if the slope is like this, what will happen to the car?
It will directly move down.
I mean, if you give acceleration along with this slope, what will happen? Rupansh,
Sir, can you repeat a question again then?
see, the car is taken from A to B on a constant acceleration on a plane surface. Okay. Car reached to an end of a plane surface. From there, a slope starts. and the slope is in this angle, one slope, next slope is in this angle, and third slope is in this angle. Now, if the car moves on this particular angle, this particular slopes, car doesn't require acceleration. Car automatically moves. If you add acceleration, the car speed get increases.
Increase, the car speed will increase.
Right? Yes or no? Hello?
Yes, sir. But
So
if the
in
slope
slope, speed increases. In slope, speed increases.
yes, sir.
Okay, because now when this particular slope on a particular speed, this particular slope on a particular speed, this particular slope, a car again moves on a particular speed. So here, depends on the slope, the speed changes. Okay, depends on the slope, the speed changes. So what I'm trying to tell you here, if no conditions are given, if no values are given, still we can find out speed of a vehicle, okay, speed of a vehicle considering slope. Interesting, because if there are no condition, no speed is given, no time is given, nothing is there, still considering the slope, you can identify the speed of a vehicle. Questioning, thinking how this can be done? Any idea?
The speed or velocity?
Speed. I'll tell you. Okay. Let me tell you this. That is slope equal to, or slope is dependent. Dependent. Are you all studied trigonometry? Are you all remembering trigonometry? Trigonometry you would have studied, right? Slope is dependent on ratio and what? Ratio of perpendicular and base. Heard about this?
Oh, yes, sir.
Slope is dependent, ratio of perpendicular and base. So take an angle. Okay. Here what is base and what is perpendicular? According to this,
The bottom side's the base and the left.
according to this degree. Okay. According to this,
The
this is what?
adjacent one is base and the opposite
This is
one is
what?
perpendicular.
This area is perpendicular. This area is base. Understood? So we are coming into laws of motions, one area, slope, and in this slope, we can identify the speed of a vehicle considering the slope. That is what I'm going to teach you here. Okay. Now in slope, trigonometry says slope is equal to tan theta. Remembering?
Yes, sir.
Slope is equal to tan theta. Slowly Max is adding to this topic. We are adding Max to these topics from this point onwards. So physics is through mathematics. Physics is through mathematics. Is it clear?
Yes, sir.
Now next, so here one condition I will stop. I'll tell you one condition and then let me stop. I think it will be boring for you otherwise. So let's see. slope is okay, or speed, make it differently. Speed equal to slope of distance time graph. Speed is equal to slope of distance time graph. When slope is more, when slope is more, when slope is more,
Distance and time are more.
speed is also more. Am I right? My dears?
Yes.
Understood?
Yes, sir.
When slope is more, speed is also more. So we will stop with this area of this class. So this very important topics from the where and all I've started. Can you, if anyone would have taken the notes, can you tell me from where I started and where I ended?
Sir, you
Points?
started by telling motion in the straight line is also called rectilinear motion and motion in one dimension. And you ended by telling that slope of distance time graph is speed.
So in between we have discussed, I've given you definition for speed, Rupansh. I've
Yes, sir.
given you definition for velocity.
Yes, sir.
Then I've given you, I told you in between displacement and path length. Don't forget
Yes,
path
sir.
length. Path
Yes, sir.
length I've told you, displacement I've told you, velocity I've told you, speed I've told you. Acceleration we have not discussed. What else we have discussed other than this?
Uniform and non-uniform motion.
Uniform and non-uniform motion. Then what else?
Kinematics and dynamics.
Yeah. From this point onwards, graph and graphical problems and numerical problems of these topics over. This topic starts, and the last topic of this motion in straight line is basically relative velocity. Okay, relative velocity is very interesting chapter where relative velocity gives a lot of questions for students who practice for JEE and NEET. Relative velocity. Okay. So maybe if I'm taking two more classes would be required for finishing this topic. Is it clear to all of you? But before
Yes, sir.
we do next class on this, try to understand the basic theory of trigonometry. Tan theta, cos theta, cot theta, all those things. Basic
Yes, sir.
fundamentals of trigonometry. Okay, before you sit next class of physics, this understand what is trigonometric rules of an angle concern. Okay, so I hope I have not bored you in the class. Thank you for joining and thank you for listening to me so much time. Hope you all will study good. Okay, all the best. Thank you.
Thank you,
Sir,
sir.
I have a
Thank you,
doubt,
sir.
sir.
Thank you, sir.
Yes, I'm here. Ask me.
Sir, when you were explaining about the concept of slope,
Hmm.
you told that when a car is moving at an inclined position, acceleration is not required.
Yes, I said acceleration is not required.
Yes, sir. So then how does gravity have to affect that?
See,
Because
the
gravity is also
condition
said to
here
be
is,
acceleration due to gravity.
Rupansh, the slope of a distance time graph tells us, okay, slope of a distance time graph, okay, tells us that when a slope is basically an inclined line. Okay, so during slope, you don't have to give acceleration, the vehicle will automatically move. Okay.
Yes, sir.
Vehicle automatically moves, you don't have to give acceleration here. If you add acceleration, vehicle will be non-uniform motion. Vehicle will move on to non-uniform motion. Is that
Okay,
clear?
sir.
That clear?
Yes, sir.
So slope doesn't talk about here, acceleration or something like that. Slope is telling whenever you drive a car on a slope, it requires or not require acceleration. If it is not required acceleration, that will try to maintain a uniform motion. If you add acceleration, that will go to non-uniform motion. You got me?
Yes, sir.
That's all. Okay. Thank you very much.
Thank you, sir.